Okay, welcome. I am continuing with the 1001 scripts, and I am finding my way slowly back into programming more and more. And I'm getting a firm understanding of the GH node in Python, and although I've been using Rhino script for a long time, I actually purchased a LinkedIn tutorial by the name of Graham, Python scripting, and I think it's worth doing in its parts. It has a fee. It seems to be worth it, and I've gotten to one script in it, and I'm not going to be showing that to honor him as a creator, but I do want to show the odd script and why it's so important and why I'm going to move in this direction and why I'll move away from Rhino script as RS imports in my Python nodes to Rhino geometry. And that's because you're starting to deal with objects instead of GUIDs. And that may make sense to some people and it might not to others, but it's certainly going to make sense to people that want to actually build geometries, which you traditionally did in a node-based system. But as you can see here, these few lines of script makes up for all the node system to actually make this piped tool. And if you actually look, it actually skips at some point. It actually, I've written in the code that it actually jumps past something by breaking and continuing. So you really can get some incredible detail when you go into the Python script in ways that you cannot do in the node scripting. So I'm not coming back from this. I'm just going to do it. And I hope you enjoy it. So let's start from scratch and shut this down and show you what actually happens in a while loop and how we can use a Python node to do that. So basically, I am going to go into my maths and grab myself the function, the Python script, and I'm going to bring it in, and immediately I'm going to go in and say I want to have a value of a height. So I'm going to take a number slider and have a number slider that goes, let's say, from 0 to 100. I'm going to set my height in here, get rid of my other variable, right-click and change the title of this as a variable to height. I am going to change the type hint to integer, and I'm going to leave it as a item access. And that's ready to go. Now all I have to do is, if I want to, in a print situation, see what's printed in the interpreter, I can see it here. And if I want to see the outcome, which will be geometries now, you can see it as long as I set A to that. And that's all you have to do in Grasshopper. That's it. Now let's get into the Python scripting and see where we can go with this. So I'm going to write the script from what I've taken down, and I have done a few things within it, so it might not make sense if I just ran right through. I'll try and add it in later. But what I'll end up doing right off the bat is getting rid of Rhino script as RS and change it to Rhino. And you'll see as I go to Rhino dot, it will give me a choice as a variety of things. And one of the most common things to use is geometry. So I can double click that, and I'm going to have that in as RG, not RS. Another thing I'm going to do in here, and you're going to see why, is I like to import math all the time because I love sine and cosine. I love trigonometry. So we'll start with the while loop, and we'll create a variable. And unlike JavaScript, if you've tried any programming that, you'll see that you can basically make something as simple as that work for yourself. I'm going to make a list, LST, the exact same as Graham does on his tutorials. And I'm going to set that to a square bracket list. And now I have created a list. And I'm going to use a while loop, and you'll see in Python how this works. While variable is less than 5, colon, it will have its automatic indentation in Python. I will take my list and I will append that variable, and then I will iterate I will increment that variable up 1 every time it runs in this while loop. And you can use the short form of plus equals 1. And so that will go from 0, 1, 2, 3, 4, 5, and then leave the while loop. I want to exit it here, come down, and continue with my script. I can print at that time list to see what's happening, and I could run that and see what happens in my script. And you can see that there we go. We've created the list 0, 1, 2, 3, 4 because we begin counting at 0. Now I'm going to create cylinders, and this is why the Rhino geometry is so cool. Cylinders is going to be a list set to a list, a blank list, and my variable is going to be reset to 1. And we're going to leave that first script, and we're going to generate something totally new, another while loop. And this is actually going to build geometries. While variable is less than height, and that's fine. It recognizes that as something that it actually wants to understand. So we've got height in there without actually having to type in any variable for it. It totally understands that that is that works with that while loop. If the variable and this is where it gets cool, is equal to 15, and you can add this type of stuff. I'm going to break, and which means if I break, it will just stop whenever it gets to break. It will leave this script, but I actually am going to use my hashtag to take that off, because I actually just wanted to think about quitting at 15, but I actually want for the variable adding 1 each time, I want it to continue. So this is very cool because it sees the continue in the script. It won't break from that, but when it gets to 15, it will choose not to write that script, and it will continue to generate what it's been doing. And I need to come back to the beginning of this 4 spaces, or one indentation, or I tab in. I will create a point, because you need to create a point to create a circle to create a cylinder, and then you'll see what I do with the cylinder. So the point is going to equal, I'll call upon Rhino geometries because it's short form. I'll create a point, and you can see how it comes up 3D. And point, it will tell you what you need down below, and I will set in the variable. And this is where I have fun with the math, accessing sine at that variable, and this is something I threw in extra. Math dot, because I want a helix, cosine at that variable, and both parentheses. I will then create a circle a variable that's equal to the Rhino geometry of a circle at that point, and then I'll just custom set. I won't have it go through a range or anything. I'll put 0.5 and close that, and then I can create my cylinder because I have all the variables needed to do that. Equals Rhino geometry dot cylinder, and that will require a circle, which I've created above, and my variable above. And now, like anything with lists, you will take those cylinders and you will append them, because you want to see them all, with the cylinder. Focus on which ones are plural and which ones are singular, otherwise you'll get lost in this, and you can use anything for variables. And you will have to also add, otherwise it will never leave this while loop, plus equals 1. And at that point, set your A, and you can see that I shifted over a little bit. You'll have to find I have to leave this loop to set A, because you got to deal with local and global variables. But I'm going to set this A is equal to cylinders. I'm not explaining this fully, but I'm showing you why I'm going on to geometries. And as I run this, if I'm lucky, you'll see exactly what happened. It ran that script, and because I haven't gotten to 15 yet, it still skips 15 when I get there, which is nice. And you can put in here anything you want. You can have the variable skip at maybe 6, and I don't want that data in my loop, and I'll run that test, and there you go. It's got it missing at 6. Very nice little access, nice little script. It uses geometry. It wobbles this way and that as it goes through it. Doesn't really behave like a helix with cosine sine, because we're dealing with vertical height. Raising it, I'd have to do some rotations to make this geometry more and more interesting. And on that note of my lovely daughter Ella, you'll also see this is generating closed breps. And I'm going to say we're well into Rhino geometry as RG, and it's a pairing of Rhino 3D with GHPython and Grasshopper. Thanks very much for watching.